we're given a table that shows the average remaining lifetime by age of women in the United States in 2008. So this data was pulled from the Social Security Administration. So it says to find a linear model of this data using 2 points. So it wants us to use methods that we've used previously to calculate the equation of the line, and obviously to round the slope to the nearest 10,000. So you will see that the first step is always to calculate the slope. So I made 65 and 19.9.2. And I made 80, 80.5, or sorry, 0, 80.5.1. And that is reflected in the formula. So I took y2, 19.9 minus 80.5 and divided it by 65 minus 0, which then gave me negative 60.6 over 65, which when rounded to the nearest 10,000th, I get a slope of negative 0.9323, which indicates that as one ages, their remaining their remaining years is decreasing, which makes sense because the relationship is that it's not like your remaining years are going to increase as you age. Your remaining years is going to decrease as you age. So then I took that slope and used the point slope form, and I used 0.1 when I calculated it. So you'll see 0.1, I have y minus 80.5, which is equal to the slope, negative 0.9323 times x minus 0. So point slope form allows me to now come up with the equation. When I expand the right-hand side, you'll notice that the 0 is gone because multiplication times 0 is 0. So you're just left with negative 0.9323x on the right-hand side. Then I add 80.5, and that gives me the equation of the line y equals negative 0.9323x plus 80.5. So now I will go to my graphing calculator, and I will show you how we can use our calculator to help us calculate these types of problems and get possibly another equation of the line for this problem. Here we are at our graphing calculator, and now I'm going to do a demonstration of how we can find the equation of the line using what's known as a regression technique or linear regression. The first thing, especially if you clear your calculator, which most people are going to do, and I cleared my calculator, the first thing that is crucial, and it'll be important, and I'll explain why when we get to that point, but for now, I'm going to show you how to do this, and that is to go into your mode, and we have to turn on our stat diagnostics. Our statistical diagnostics have to be turned on. So I'm going to turn on my statistical diagnostics. So now that I've done that, I can leave this, so second mode to quit and leave that. So now we can go ahead and take our data values and place them into a table of values. For that, we have to use our statistics package. So you need the stat function. So you press stat, and we need to create a list. So we will edit a list. So I will hit enter or 1. And I will enter first the X values, which is age, which if you remember from the table, we have 0, and then we have 20, 30, 50, and 65. And the remaining years variable Y, we have 80.5, 61.2, 51.5, 32.7, and 19.9. We've entered all of our data values into a table, which is on our calculator. Once we've done this, we go back to our statistics package. So we click Stat once again. But at this point now, what we need to do is calculate or use the calculate functions, not the edit functions. So what we have to do is what's known as a linear regression. It'll give us the equation, or it'll give us the values of A and B. So we can perform this calculation. So if you press 4, it's going to then take you here where you have to determine what your X variable is, which is L1, which is how I set it up already, what your Y variable is, L2, and what we don't need a frequency list in this case, so we leave that blank. And we don't need to store the equation, but I'm going to store it anyway. So I'm going to go to vars and select that I want to save it as a function in Y1. So I'll hit enter. So I've done that. So now that I have that, I can go ahead and calculate everything that I need for this equation. So I hit enter one more time, and I have all the values that I need. You can see that the slope that we calculated is pretty close to this one. So you would end up with an equation of y equals negative 0.9356x, right? Because we're rounding to the nearest 10,000th, plus 80, basically. So the 80.5 is gone. So it's plus 80. So we will leave it like that. What I wanted to point out to you is the R value. Now, we don't look at R squared because we're focusing on how positive or negative the correlation is. We're just looking at the R value, which is the second of the two values. This one right here that says negative 0.9997, so on and so forth. This indicates to me, this number here is a very strong correlation. And given that it's negative, it's so close to -1 that we could say that the line that represents these data values is going to be indicating that all the points are going to be very close to that line if we were to plot the scatter plot. So it is a very strong negative correlation. We can even graph it on our calculator. So you remember I stored the equation. You can see up here, if I go to y equals, the equation was automatically stored and the calculator doesn't round anything off. So all of the values are there. And actually we could graph it, but we wouldn't see it because our window settings are not appropriate. So now we can go to our window settings and make sure that we can see the entire function. We do not need the negative X values because age is not negative, but we do know that they go up to 65, but I'm going to go a little bit further. I'm going to go to, let's say 90. And my scale on my X axis, I'm going to make it 10. The Y minimum, also, we don't need to make it into the negative. And the maximum, remember the highest remaining years was 80.5. So the maximum, we will make it, let's just go 85. Actually, let's do the same as the x-axis 90. And again, making the scale 10. So we can graph the line now, and we will see it on our page when we press the graph button. And there is our linear function. And we can even take it a step further and get a visual representation to see if our points are very close, and they should be very close to this line, given what the R value is, given that the R value is so close to -1. So what we can do is actually we can go to what's known as the stat plot. We want to plot our values. So we go second y equals, and this will allow us to turn on, we can turn on the stat plot, because right now those points are not plotted. So we could turn it on to see our data values. So now that it is on, we can go to the table and we see that the points very much, if they're not on the line, they are very close to the line that represents this scenario. So at this point, we can actually rewrite our linear equation as follows: y equals -0.9356x plus 80. So let's look at the next part of this question. So for part B, we are told, based on your model, what is the average remaining lifetime of a woman whose age in 2008 was 25? And it wants us to round our answer to the nearest year. So use the linear model that we have just calculated, use the one that we used with our calculator, and calculate what the remaining lifetime is of a woman who is 25 years of age. If we use the equation that we last calculated, the -0.9356x plus 80, we substitute 25 for x. And once we do that, then we add 80 after we multiply 25 times -0.9356 times 25 plus 80. We will end up with a result of 56.61, which rounds to 57. Well, I'm going to show you one last thing with the graphing calculator that will allow us to calculate this using the graphing calculator. So we're back here to the graphing calculator, and I've left all of the data values that I calculated here so that we can all take a look at this together. So again, all of our points are still there and our line is still there. And we were told to estimate the remaining lifetime of a woman, the average remaining lifetime of a woman who was 25. So we know the X value. When we know the X value, we can calculate what the average remaining lifetime is using the calculate functions within the calculator. Above the trace function, there is the calculate functions. So if we press second and trace, that takes us to the calculate functions. Now, when we are given the X value, we can use the very first, and substitute or input a value for X, and that will give us the exact number. So I press 1 and I input 25. I press enter, and that gets me an answer of 56.64. So using our model, we can say that the average remaining lifetime of a woman in 2008, if she's 25, the average remaining lifetime is 57 years.